Good afternoon, everybody. Thank you all for coming out to the summit, and thanks for attending this session on delivering search for local, mobile, and social applications. And as we get into it, I'd just like to ask everybody to think back on the last search that you made, the last time you were online, potentially searching, and how many of those searches, raise your hands, how many of those were socially focused? So some, okay. And about how many of those involved some kind of local context or location-based information? So a lot of those. So as we get into the material, we'll see that search, and especially location-based search, is a really key growing component of what applications do need to deliver. And we'll talk about sort of some of the statistics and some of a little bit of an overview of what's going on out there with search and social sites. We'll look a little bit at Amazon Cloud Search, and I'll give you a feel for how to get started with Amazon Cloud Search. And then we have three fantastic customer stories that we want to bring to you. First of them is Ziplist. Ziplist makes grocery shopping a breeze. You can plan your weekly trips to the grocery store. You can organize your foods. We'll hear from Tim Ramsay. Second one is Zumobi. Zumobi is a leading media company that partners with media brands to provide mobile applications with an integrated ad experience. And we'll hear from Pat Binkley on the end. And then we'll hear from Ken Chung of Vidi. And Vidi is a mobile app that makes capturing, producing, and sharing short video segments easy. So it's somewhat of a truism that we're all spending more time online. And with the internet everywhere, we know the use of the internet is actually growing. Now this is an infographic by gogolf.com. And how do people spend their time when they're online? Perhaps not so surprising, 22% are spending their time on social networks. But really surprising for me, 21% are spending their time searching. So search, just in terms of time spent online, is actually a really large segment of what people do. And if you look at it, search is actually more people are searching than they are either reading content or reading their emails. So search itself is something that we have to deliver, or is taking up much more of our users' attention, and we should work to deliver good search because it's a major component of what people are doing. And looking at in the social space, again, what are people doing? 70% of them, I know this is a little bit hard to read, the 70% there people are sharing their experiences. Okay, in the social space, 70% sharing their experiences, not a big surprise. The other numbers there, though, represent what people are doing with respect to brands. So they're learning about brands, they're talking about brands, they are also sharing coupons, they're doing all of these kind of things. And I just want to take that thought a little bit farther even than specifically products, because when people share ideas and these ideas become current, well, in 20 to 50% of the cases, they result in sales. But even in a broader context, it helps ideas spread. And in terms of applications, as people connect with one another, we want to allow them to move their ideas forward. And again, the search comes in here because as people are searching and using the application, we want to bring to them the stuff that's relevant to them. So the stuff they want to buy, the people that they want to connect with, the content that really matters to them. We want to bring all of that to them, and search provides us the means of doing that with relevant results. There's another BIA-Kelsey study, and this is what is the ratio of mobile search to desktop search. And you can see in 2011, it was more than 2 to 1 people were searching on the desktop. As we go through time, though, we see that the number of mobile searches increases and actually will exceed the amount of desktop searching in around 2015, according to this projection. So again, people on mobile devices are going to be searching, and as they're doing that kind of searching, this one is also from GoGolf, the largest growing portion of that search traffic is targeted at a location-based or location-aware services. So people are searching more with mobile, makes total sense. They're searching with mobile. They want to know stuff that's relative to their location. They want to know stuff that's near them. They want to know, what's around them, what can they do. So given that search is important and growing, and we want to put it in our applications, so how can we do that? And really, even beyond search itself, search has even become a doorway to the experience of content and of even application functionality in a mobile space. So there's several options out there. We have a build your own. So you could create, using a database or similar code that you create, a search experience. Beyond that, there are open source solutions that allow you to deploy search engines and bring search in a organized search engine. And finally, there are some legacy enterprise-grade solutions that will bring extremely large-scale search to an application. But all of those have different challenges. So for building your own search experience, search itself requires custom algorithms, highly tailored to provide low latency results. And there's, in fact, an entire discipline of information research that tries to figure out how do you get the right stuff and bring it back to your users. So in a roll your own kind of environment, search is a complex challenge to accomplish. And beyond that, search is a grid-based kind of algorithm. So there are challenges with deploying and maintaining hardware, maintaining software. In the open source world, there are challenges with partitioning data, getting it deployed correctly, getting it replicated. And all of these challenges make search hard to deliver well. And, of course, that's not, generally speaking, the core competency or the core mission of your companies. So Amazon Cloud Search came out about a year ago, and we released Search as a Service, incorporating many of the benefits of AWS and really even within a search context, providing those benefits with Search as a Service. One of the big challenges with search, again, is figuring out how many hosts you need to serve your search problem. And not only that, there's, generally speaking, there's variation either daily or seasonally in the amount of hosts that you need. You have to pay for all that infrastructure to serve the highest traffic level for your search. With Amazon Cloud Search, we write scale. You pay for what you need when you need it. There's a lower total cost of operation. Amazon Cloud Search, again, because it writes scales and because you don't have to focus on operations, it provides search to you at a lower cost. You don't need to guess a capacity, as we said. You don't have to know what your seasonal peak is going to be this year. You can simply rely on Amazon Cloud Search to scale for you. Because it's low cost, it allows you to innovate quickly with low risk. We do all the undifferentiated heavy lifting. That's a hard one to get out. Doing the operational and software maintenance tasks. And it's available currently in 5 regions. We're in US East, US West, Europe, and Singapore. And you can go global in minutes, as with most of AWS services. So let's have a quick overview of Amazon Cloud Search and sort of the architecture and interaction that you have with it. When you get started with Amazon Cloud Search, you create a search domain. A search domain wraps everything that all the software and hardware necessary to provide a search engine for you, There are 2 services that are deployed into your domain. The first, of course, is a search service. This is available over a stable DNS entry, and you use HTTP GET to pull search results from your search engine. There's a document service. This is an endpoint, again, stable DNS entry, where you use HTTP post to post your documents, your search documents. And as you post those documents, they're indexed, deployed into the running search domain, and available for search within a few seconds to a few minutes is our general guidance. This all happens behind DNS and load balancing. All of that's taken care of for you. And you're able to just use HTTP post and get to interact with the service. In addition, we have a configuration service. This is behind regular AWS query, also available in the console. And we have a suite of command line tools that allows you to control the contents of your domain, how the indexing happens, some language options, and adding and deleting search domains. So administrative access. So a quick look at cloud search in context. I have an architecture diagram which has a kind of a standard web application architecture, including load balancing, some web servers, and a database server behind it, or some kind of information store that's holding the main content of the application. In order to integrate with search, because it's a RESTful API and because it's all available over HTTP, you can create a search domain. Your web servers can send traffic, send queries to that domain, retrieve the results, construct the search result page, and display it back to your user. In addition, as you make changes to your data store or your database, you'll have a process running that will pull new information out of your database and apply updates to your cloud search domain. So really, the overall integration picture is quite simple. Simply send data and get search results. And I do want to bring out just a couple of points on the elasticity of cloud search. When you get started, you'll start on a single, what we call search instance. And again, a search instance is storage, compute, and networking, and everything you need to run a search engine. You'll start out on a small. As you're posting, not going. Did we die? We died again. So as you're putting your data into cloud search, we are, again, indexing that data and deploying it into the RAM that's in the running instance. We don't need our animation yet. As the RAM fills up, we would then move you from a small instance to a larger instance, and then to an extra large instance. And now, if we have our animation, so you would, again, move from a single small search instance to a large search instance to an extra large search instance. If you keep sending in data, we'll automatically partition that data and deploy the two partitions to two separate instances, load balanced. All of the query is distributed evenly. The results are aggregated across that. All of this happens in parallel on the side with no intervention on your part. You just send data. Oh. You just send data. And if you continue to send data, actually, we'll eventually partition you out even wider. So we'll continue growing your search domain with hosts to handle the data as you send it in. We'll also scale to handle traffic as you send it in. As you're sending traffic, we're using CPU on each of your partitions, each of your instances of your partitions to serve that traffic. If the CPU tips over an 80% point, we would then add additional replicas of all of your partitions to serve the additional traffic. And indeed, if you would grow with more traffic, we would add additional partitions. And as an AWS service, if your traffic shrinks back, we would then remove the unneeded extra capacity. So cloud search really is elastic in data, allowing you to send in as much data as you need, delete data, and elastic in traffic, allowing you to send traffic, and will right-size the resources used for the traffic and data that you've sent us. One quick note on pricing. For the single small instance, you can get started. It's just $2.40 a day in East. When our guidance is, this would hold approximately 1 million documents of 1K each, $75 a month. and you can be up and running. We recently added a tab to the AWS calculator. You can game out some scenarios there, look at your data size, look at your traffic, and sort of figure out what this is going to cost. But very inexpensive to get started. And even less expensive to get started, we're running a free trial now. Your first 30 days of usage of Cloud Search are free. So come check us out. I am going to turn it over now and introduce Tim Ramsay. Tim Ramsay is one of the founders of Ziplist, currently the chief architect, serial entrepreneur, having started up 5 successful companies. He likes distributed computing, Lisp, and snowboarding.
Thank you, John.
Sure.
I'm honored that the AWS folks asked me to talk to you today about Ziplist and about the way that we use Cloud Search. Cloud Search is a part of what we do there at Ziplist, but it's not the entire thing. Ziplist is a fairly large, does a bunch of other stuff. I wanted to give you some context about what Ziplist is. It's really overall, it's pretty simple. It's an online shopping list and a recipe box and recipe management tool that you can use. We have 2 different kinds of recipes, and I'll go into that in a little bit more detail. But in our global index, what I call our global index, we have about 1.6 million recipes. That's apropos to this because that's really what we're indexing for Cloud Search. And then out of that 1.6 million recipes, about 25 million of those are in recipe boxes. So John can put a recipe in his recipe box, and I can put the same recipe in my recipe box, and that counts as 2 of those. And we have about 3.5 million registered users, and we have iPhone and Android mobile apps, and about 315,000 downloads for those two things. Another important aspect of Ziplist that I'm going to touch on here, because it does deal with recipes, is our partner strategy. We have 2 kinds of partners. We have white label partners where we're pretty tightly integrated. They have a recipe box and a shopping list on their website, but in reality, that's the Ziplist website. So when you go to that partner's recipe box, and when you go to the Ziplist recipe box, it's actually the exact same recipe box. You see those same recipes. And then we have over 1,500 what I call recipe partners. These are pretty light touch partners, but it's a crucial way that we get recipes into our system. And we're talking about a small food blogger or something like that. If you go to darcydiva.com, she's a small food blogger. You can see an example of this, where she has a button on each of her recipes that says Add to Ziplist. And when you click that button, it adds that recipe to that user's recipe box. In the process, if we haven't seen that recipe before, that recipe is put into our global index, and then it's put into that user's recipe box. So that's sort of how that works. And lastly, to give you some context of sort of the hardware, software, platform infrastructure that we're using, we use a lot of Amazon. We use EC2 for our compute stuff. We use S3 to store logs and those kinds of things. We use RDS as our database backend. And of course, we use Cloud Search for our search solution. And on the software side of things, it's a pretty standard Ruby on Rails stack. So talking about recipes, we get recipes essentially by indexing web pages on the web. And those web pages come in a variety of flavors. Some very structured. If you go to allrecipes.com, you'll see very structured recipes. If you go to a site like Saveur.com, you'll see very unstructured recipes. Saveur is a beautiful website, but their recipes are really just sort of hand-done and ad hoc and that kind of thing. And then those recipes, if the publisher is really tightly integrated with us, that publisher can actually use an API and push that recipe content to us. But more often than not, that we pull the content. We pull the content either by the user pressing the Add to Ziplist button on some recipe site, or there's a browser plugin which does effectively the same thing. It pulls the recipe into the system. Once again, every recipe goes into that global index, and then users can choose which of those global recipes to stick in their recipe box. And on the left side here, on the right side here, my left, you'll see the kinds of things that we index on recipes. These are all the attributes that go into cloud search. We have 2 search domains. I'll talk about that in a little bit more detail. The global recipes as well as the recipe box recipes. And the asterisk ones, we have slightly different attributes that we index in each of those domains, but the asterisks show you the ones that we use in the recipe box. So how did we get to cloud search? We got to cloud search because we went through a couple of other tries. We started out with Ferret. Ferret was a very easy integration for us. But as we grew, we saw some stability problems, some load problems, and decided to look for another solution. We came up pretty quickly with Sphinx, well known, sort of tried and tested, and that solved our stability problems just fine. But we still had some load problems, especially as we tried to address what I call our latency problem, and I'll talk about the latency problem in more detail. And then, so that led us to look around to find us an alternative to Sphinx, and we came up, did some experiments with cloud search. Things looked pretty good, and so we flipped over there, and it's been good for us. So here's just sort of a high-level flow of sort of how a recipe goes through our system. It comes in off the web. Either, like I said, either pushed or pulled into the Ziplist system, goes into the global index there, the ZL recipes, and from there, users can add those recipes to their recipe boxes. So I've shown 2 users here. They're adding recipes to their recipe box. And then we have, off of the global index, we create our SDF documents, which are the search definition documents that cloud search, that you actually send to cloud search. Those are the documents that are indexed. We do that off of the global recipes, and then we do that off of the recipe boxes as well. And so we have these two separate search domains. This is actually very good for us, because one of the things that it allows us to do is it allows us to have this uniform search experience between a global recipe search and a recipe box recipe search. Users really don't sort of know the difference there, but for us it's a fairly significant difference. This allows us to sort of unify that feel and the way that system behaves, all those good things like filtering and faceting and those sorts of things that users expect. If we didn't have any other problems, I'd be finished now. But I did want to talk about sort of the challenge that we faced. We faced this with Sphinx, and we also faced it with cloud search. And I'll talk briefly about how we sort of fixed that. But here's the scenario. A user goes to a website like epicurious.com. They see a recipe. They add it to their recipe box. And then they immediately go to Ziplist, and they look for that recipe in their recipe box, which is being filtered by Epicurious. So that's maybe a 5 to 10 second operation. It takes them to do that. And it's a very common thing to do. They add a recipe, they go to their recipe box, and they sort of look at their other recipes they've got in there. So because there's this delay between for the generation of the search definition documents, and then once you upload it, there's a little bit of a delay to index that document. This is problematic because that view of the recipe box that user is doing, when that user filters by Epicurious, that view is really a search query. We're searching on that user's recipes by Epicurious and filtering it by Epicurious. So that's the problem. We had that problem with Sphinx, and we have that problem with cloud search. And I'll just briefly go sort of, I think there may be some panel questions maybe about this, but I'll briefly talk about our solution here. This is the same sort of picture as before, showing you sort of the users adding recipe to their recipe boxes. But what we've done is we've added a caching layer when the user adds a recipe to their recipe box. This caching layer is active only in that interim time between the generation of the SDF document and that being available in our cloud search index. And then we put a little query module there that actually integrates the cache results, which are usually very small because we're talking about just particular users in this case, and the cloud search results. And this actually works really well for us. It's a great workaround for a problem that was kind of ugly for us. Anyway, so resolving the latency issues, the cloud search, like I said before, works really well for us. It has all the great features that users are looking for when they're dealing with recipes. You can filter by all sorts of things. You can order the recipes. One of the things that we do is we nightly compute sort of a quality or a popularity score on recipes. We augment the cloud search records with that information. So the users get really relevant and sort of trending information in their recipes. It's great. The other thing, as I mentioned before, we have this consistent interface between our global search, searching the 1.6 million recipes, and the recipe box search. We're able to make that look very, very similar, which the users really like. But also, we have a consistency between our web experience and our mobile experience, because our mobile apps do all the same searching and everything like that. So we are able to provide the exact same search results, the exact same power on those search results via our mobile apps as well. And lastly, I'll say that cloud search really positions us well. We very much want to move some of our database storage and processing to NoSQL solutions. It's a very, very good application for that. And cloud search really positions us well to do that. And now I am finished. So thanks, John.
Thanks very much. OK, so I am going to bring up Pat Binkley from Zumobi, VP of Engineering. He's responsible for overall product development, 15 years of experience, and yes.
And I like to ski instead of snowboarding.
Oh, likes to ski instead of snowboarding. Good to know.
I got hurt a few times.
You'll probably want to have this.
Sure, thank you. Sure. So I work for Zumobi, and we are a mobile advertising company. We have an SDK that's out on the web for app developers to download to put ads into their apps. We view ourselves as sort of a high-end mobile advertising company where we provide deep sort of native mobile ad experiences. And for a handful of mobile applications, we actually build as well. And so I'll be highlighting one of the apps today. So the product that I mentioned out on the right-hand side there is, it's called ZBI. That's our ad SDK that can be downloaded. We've been around for about 5 years, actually 7 years, time flies. We are originally a spin-out of Microsoft Research, and we had a vision where we were going to build an application platform where developers could build small apps that could be downloaded from app stores. And we basically rolled that out on BlackBerry and Microsoft Windows devices. And then this little thing called the iPhone came along. And so we sort of dusted ourselves off and repositioned ourselves in the mobile advertising space, which is where we're at now. Today I'm going to highlight the Week app. This app has about 250,000 active users. It's one of my favorite apps because it presents an in-depth look at the news without having an opinion about the news or without slanting the news. I'm very proud of the fact that this is a 5-star app. It's available in all of the app stores, including the Android App Store, which I'll throw that pitch out there. I should say the Amazon App Store. It's in the Android App Store right now. So what we did with this app, you can see the search icon in the upper right-hand side. We wanted to have parity with the desktop experience. We wanted to offer all that same rich content to the Week users as the desktop users. We are huge fans of Amazon Web Services. We use all of their products, and we have for since about 2007. And so when Amazon released the cloud search feature, it made a ton of sense for us to look at that and implement it into our apps. And so the problem that we have is all of our apps, we essentially design for a local data experience. What that means is that as users are navigating between sections and they're navigating between articles, we're not going out to a server to get more data. We can run in a complete offline state. And so that's great for performance reasons, but what it means is we have to download all of the data at the beginning of the app startup experience that user is going to consume. So we're smart about it. We compress the data. We put it in a SQLite database. We do everything that we can, but it means that they can only download about maybe 100, 120 articles. So the problem there is that if a user wants to search a database of 100,000 articles, you really can't do that on a mobile phone. And so this is where cloud search comes in. We essentially store the clouds and store the documents in the cloud, and we query them from the app. So with this new feature, we introduced keyword searching, and you can see some of the screenshots there of the app. And that also includes relevant results. And that's an important part of search, tuning the results that you get back. Do you want them sorted by date? Do you want them sorted by the number of keywords that show up in the actual articles themselves? That's a key component. We were really pleased with the Amazon, the relevancy. We also, when you are inside of the article viewing of the content that you searched for, we actually highlight the keyword. So whatever you searched on, in this case we searched on Tokyo, you would see that inside of your article. One of the key features of this is that what we found is that users are very passionate about what they've searched on, right? I mean, you can browse through an app and maybe you choose to read 3 articles in the whole app, but with search you're very passionate about it. You're hunting something down, and so if in this case a user finds an interesting article about Tokyo, they're very, very likely to share it out to their social networks. And more importantly, they're also very likely to save that article for later. They may actually even save the top 5 articles. In this case, this app has fairly long articles. And so they're very passionate about this content. Once they've found it, they don't want to lose it. They want to hold on to it, and they want to share it with their friends. Oops. Okay, I'm going to hit the forward button. There we go. All right, so here is our marketecture slide, you might say. This is how it all happens under the hood, and it syncs up, I think, with some of the other slides we've seen today. We, in the upper left-hand corner, think of that as the week.com, the website, the publisher. Our platform, which is really a giant you might say, process and database that goes out and gathers information from not only the Week, but the other publishers that we work with. We essentially pull all that information and we distill it down into the SQLite database that I was telling you about, which is in gray here. That's for regular usage and browsing of the app. We try to keep that as small as possible. But as we are processing that data, we are sending it all up into the Cloud Search document service. And for items over 2K, we have a lot of images and long articles. We will store it out on S3 and sort of complement the offering. And so, the business that we're in, the latency of 10 seconds, that doesn't really hurt us too bad. So that wasn't something that we noticed or really affects us. But if you're in that, in that scenario, I can see why that would be something that you would want to work around. But then on the flip side, really the user will search for the term, and within a few seconds, they have a very relevant list of content delivered back to them. So some of the things that we've seen, it's very early on. We've only had this app update out for about 2 or 3 months. But what we're seeing right now, and the most obvious one, is we have feature parity with the week.com, the website. We also, inside all of our apps, there are user feedback mechanisms, which everybody on the team sees. And so we have seen over the years a lot of requests for search inside of this app and the other apps that we build as well. And so those requests, we know that we're sort of addressing user feedback. We have seen increased usage. I haven't quantified it yet. But early indications show about 3% of the overall app traffic is now spent inside of search. And if you look at that independently, it might not seem like a lot, but you add one feature to the app, you generate 3% of your usage. That's pretty good. Imagine if you add 5 more features. So we're seeing increased usage. Via the social sharing, we're generating new users. Users are seeing articles in their Facebook app and then downloading the app. And so it's sort of a whole cycle that feeds on itself. And then the data collection. We can, with the tools, you can get in and you can see what users are searching for. If I'm an editor at theweek.com and I see that users are searching on North Korea or Tokyo, I'm going to amp up my editorial process to focus on what it looks like my users are searching for. So this is sort of a mishmash of some of the apps that we build, but you can see that we have about 50 publishers in the network right now. The Week is the one that we updated. We're planning to update our NBC News app. Some of you might have the NBC News app on your phone. That app is scheduled for sort of an early to mid-June upgrade for search as well. So we plan on putting search across all of the apps that make sense. We also build all of the apps for sporting news. I can see a huge value in being able to just search for a player or search for a team. It's quite, the opportunities are endless there. So my shameless plugs, if you want to learn anything more about Zumobi, feel free to go to zumobi.com. You can also find the Week app itself in the Amazon App Store, the Android App Store, or Apple's App Store. And that's all I had. I wanted to thank John for inviting me here to share our solution with you. Again, I'm a huge fan of Amazon Web Services, and we were thrilled to have Cloud Search released.
Thanks very much, Pat.
Thank you.
Really, I like what you brought out about user engagement and how people really are tenacious about the stuff that they're searching for and how that's really meaningful. And I think it just, again, it goes to bringing content that users want, increases engagement, as you saw, and I think it's a great story. So we're going to move to the media space a little bit, or video space. I'll introduce Ken Chung, CTO of Vidi, and he's going to tell us about Cloud Search in video.
Thank you. Thanks for having me here, John. So let's see. OK. So first of all, I have a question. How many of you already have a search solution in place right now? OK. And the rest of you, I assume that you're thinking about having a search solution in place, right? OK. So Vidi is a simple way to capture, create, and share 30-second social video with friends. And then we're very mobile-focused and mobile-first company. So having that very location awareness, and then having relevant context around interests and hashtag and all those things are very relevant, because there are millions and millions of contents out there, and then a lot of time you want to consume that is most relevant to you, and that was our search challenge. So this is a kind of snapshot of extended view of our 2.0 product. So in the left cabinet, you see in the first cell that you're going to see a location-based search. So wherever you go, when you just slide it open, you're going to see everything that is around you. And then below that, we have some cells around the hashtags, and then also some of the search result based on keywords. And on the right panel, you also see a user search based on username and user phone name and their country information and all that. So that's kind of like everything is powered by Cloud Search. So I mean, our search use case is nothing different from a lot of you out there. So basically, people want to discover content around them, and then people want to find their friends and celebrities. And then they also want to discover content with certain hashtag and keywords. And then they want the search result to be very relevant to where they are by language, or that they speak, or the country, everything around the context. So this is not exactly unique to Vidi. So every mobile company will have a similar problem, because especially with the location information becoming more relevant to mobile apps, this is not a problem, again, very specific to video. So, I have to think, like, why does everyone try to reinvent the wheel when, and then basically a lot of time is spent on setting up the infrastructure, and then setting up all the logistics, and then when you have a lot of users, you have to think about partitioning and all that, which is a lot of headache. So before Cloud Search, we actually had a search solution in place. We had a Lucene-based search product, and then we had a custom indexer and the search API servers, and then we had a fully dedicated development research working on the search product. As you know, Lucene search core is not exactly friendly to non-developers. So, having that dedicated resource just cracking at the search relevancy and just optimizing query was important. And then it just was a full dedicated resource on that. And then, you had to build the custom tools around monitoring and the management and all that. So, and then we had this very unique situation, which is fortunate, but some people say it's a good problem to have. Our user base went from 300K users to 40 million users in 6 months. And they gave us a lot of issues and problems and headaches, because we were really happy with our search product, and it was we first vertically scaled, having large memory instances and holding all the search index in memory. So we were happy, So we're optimizing query with a dedicated development effort, but with 40 million users, it's a different ballgame. So you have to partition out, and as John mentioned, it's a grid-based. So it's, you can't basically just shard it out and then, everything works just like magically. So, and then we ran into this Cloud Search. So one day I got that email from Amazon saying, hey, we have this new product, check it out. So it was particularly interesting because, it was managed Cloud Search product, and it seemed to tackle a lot of the problems that everyone has. So, we, gave it a try. So, we tried it out and then did the first prototype, and then one engineer built it in 7 hours. So it was fully working, and then everything looked great. So we said, hey, let's actually give it a try in production. So we actually migrated all the data and then implemented everything in 3 days. And it was really simple and straightforward to implement, because it's just simple 2 REST API endpoints, one for indexing and one for querying. And it was so simple. I mean, I keep saying this over and over, but it's not. It was there wasn't any trick or anything. It's just a good, solid foundation block for search. So before we're spending, as I mentioned, we had a full dedicated kind of like resident expert on search. But then after that, we only need to allocate like 2 to 5 hours a week just looking at this product, optimizing query. And what's really nice was it provided all the monitoring and all the console dashboard needed for anyone to just go in and optimize query. So right now, like, our interns are helping out with the search query result, so which is really hard to do before Cloud Search. So that was particularly nice. And overall, we used to spend about 5 to 6K a month on search product, compute instances and just storage, and then actually having someone dedicated, spending a lot of time on it and managing it and the DevOps and all that. But now we're roughly spending about $600 a month, which is a considerable saving. And then also, we were actually able to revamp our search. 1.x version of our product didn't focus a whole lot on search, but with 2.0, just because we could, we had all that option of geolocation-specific search, better hashtag search, and the media keyword search, and all that. So we were able to do it because we could, and we could afford to do it. And then after 2.0, we're seeing a 5 times increase in the search usage. And before also, the average delay of incremental search index update was usually 15 minutes, because we batched everything for 15 minutes and then just updated the index. There was issues with the fragmentation of index and all that if you do it too often and whatnot. But after migrating over to Cloud Search, we don't have to worry about that. So average time for a piece of content to be available in fully searchable is around 30 seconds, which is very acceptable for our needs. And then also we are also, just like Tim mentioned, we're aggressively using cache and some of the tricks that he mentioned, and similarly to kind of like, you know, to hide some of the delay to the users. So that's about it. So
great. Thanks so much, Tim. Am I on? Am I on? I am on. Thanks so much, Ken. And 3 days to migrate entirely to cloud search. Pretty amazing, actually, I think. And so we're going to have a little bit of a customer panel. We have some questions. And I'll just toss out, first question, how long did it take to migrate over? We can start with Tim.
Let's see. We ran a lot of prototype experiments up front to test out the feasibility of doing that. And so it's a little bit difficult to tell because a lot of that code that we used for those prototypes ended up becoming production code. So, but it really wasn't very long at all. I would say maybe all told from beginning to end about a month.
About a month, yeah. Including upfront testing,
including
development,
that sort of
proof of concept, all of that
right,
stuff.
Right.
Excellent, excellent. Pat?
So for us, we didn't have a search solution in place, so we were putting in something new. But I would say the Amazon portion of our efforts were about a day. So I had a developer on the team take a look at the documentation. We signed up, and within minutes, I think he was up storing. Well, first he created a domain, and then he was storing documents, and then shortly thereafter querying documents with the APIs. So our overall time was about 5 days, but 4 of the days was really just the UI work and the presentation and the saving and the whole comprehensive feature. So really, it was just about a day. It's a very straightforward implementation.
And I think, that's for us, that's very on mission. We are trying to bring search very simply and make it easy to integrate with everything. And it's great to hear that that's actually working out, that people are able to adopt search, get it up and running quickly, and get it out there. I think that's fantastic. So just a general question, what advice or any lessons learned would you have for people considering adopting cloud search?
So I think, I urge everyone to just try it out because it's so simple. And then especially if you don't have an existing search solution in place, I think that's going to vastly change the user experience using your service, especially if it is a consumer-facing product. So, I urge everyone to just try it out, and you'll be really amazed how simple it is.
Nice, thanks. Anybody else want to add?
Yeah, I think everybody will come to their own opinion. Everybody's going to use the search solution differently. You may find that it might not work for you, but it's only going to be a few hours of your time to sort of set up a prototype and figure that out. So I agree. I think just give it a try and see how it goes.
Yeah, and again, I think that fits nicely with the increased innovation message that we really want to provide low risk, easy to use, a test bed that allows people to try stuff out, to discover new functionality and new features, and bring those features and make them live. Okay, another question. So has cloud search changed the way that you do development? How about Tim?
I would say yes, it has. In particular, as we start to architect out, I mentioned this briefly at the end of when I was talking. As we start to architect out our NoSQL solution, the fact that we have cloud search in there really is affecting the way some of that architecture of what we're going to do. In a large way, the challenge for us is to replace that relational data structure that we have now with how do you fit that relational data now into a NoSQL style approach. Well, it turns out that with a powerful, easy search solution like Cloud Search, you can actually replace some of those SQL queries by cloud search queries. Frankly, a lot of those SQL queries are ordering or searching or filtering data. Cloud search does all of those things very well. And so like I said, as we consider that architecture, cloud search plays a crucial role in how we're going to do that, how we're going to work that out.
So opening up new frontiers a little bit, a different way of looking at a problem.
Exactly.
Yeah, I think from a product perspective, Zumobi builds a lot of news apps, and one of the ideas that's been floated is providing local news around you, and that's not something that we've ever really thought about doing, or if we did think about it, we thought, oh boy, it'd be a lot of work and not a lot of payoff. But to have a search solution almost hand you geofencing capabilities around news articles is really something that's giving us something to think about, and it's opening up a whole new product feature set for us. So it's not going to necessarily change our development process per se, but it's definitely changing our thinking.
Right. Yeah, Ken, I mean, you've talked a little bit about the resources used to do development, and anything to add to sort of that?
So, I mean, we have a very lean staff of 8 developers, and that includes all the client-side developers, DevOps, and backend. So we have very much like a dedicated DevOps and dedicated backend. So it's hard to pull off their attention away from the main product. So after migration to Cloud Search, we really lifted ourselves from the old headaches. I mean, like search is, to be honest, is a headache, So, so it's just being able to do that, and then having their time more focused on the innovation and differentiating factors instead of just going through all the heavy lifting of everything that everyone does. Really helped us, and then just being able to utilize non-technical people who has a good logical sense of how queries should work can just like go into the console and just like play with the expression, and then they can sometimes come up with better query, which is an awesome addition to how we operate.
So even opening up to even non-developers can now interact with the search experience and provide improvements and, and other stuff. So put you a little bit on the spot. If you guys are comfortable, can you share some traffic numbers with us in terms of number of queries, size of the data? If you guys aren't comfortable, we can move on to another question, but anything you want to add in terms of the scale of the data that's in Cloud Search or the usage of Cloud Search?
I'll just be honest, our app, we have about 250,000 active users a month. The number of times users go to search, I feel very confident that Amazon is going to be able to support it, but our numbers are in the tens of thousands, but that's just because it's a smaller app and it's a niche. But I know that as we expand it into other apps in our network, we have about 10 million active users across our network and around 250 million page views a month. So I feel very comfortable that Amazon will be able to support that load with the auto scaling that they do and the scaling of the indexing. Right. So I don't feel like we're there. I'm just being honest right now with volume, but I feel comfortable that when we get there, we'll be okay.
Right. Right.
Yeah, there certainly is that aspect of being very comfortable with the scalability of the Cloud Search solution. We have very sort of periodic usage patterns throughout the week. People do a lot of recipe planning and shopping on Sundays, and you can see that sometimes so much of that our Cloud Search will actually expand out in that in the dimension that John showed, in the downward dimension, where we're getting a lot of search traffic, people searching for recipes, obviously meal planning and figuring out their shopping lists. So I don't know, I actually don't know what those numbers are exactly, but you might be able to back into them by figuring out how much load it takes to expand out in that next dimension.
Right. Yeah, that spiky traffic is one of the things that, again, we allow you to handle more easily with the automatic scaling. Okay. So this is a little risky one. What was an unexpected challenge that you came across in migrating over to cloud search or in building search for your application?
Well, you know, one of the things I thought that was great about this team was they called us and they asked us for feedback early on in the process. And I think we felt like we were nitpicking a little bit with the feedback, but some of the feedback from the main developer that implemented this was he said it took a long time to essentially fire up the domains. I don't know what a long time meant, whether it was an hour or 45 minutes, but it seemed like creating the domain took longer than he would have liked. Maybe he was just being impatient and wanted it done sort of immediately. But I've noticed that there's other services, you know, like Redshift, I think, takes 15 minutes to provision. But once it's up and running, you're up and running. I think that we also found that the reporting and the analytics needed a little bit more work, but that's easy to fix. I mean, I think we were one of the early customers. So I think most of our concerns fell into sort of nits and gnats. And the fact that they were asking us, what do you guys think? And they've probably since fixed and addressed a lot of those concerns already makes me feel pretty good about the relationship moving forward.
Great.
So, I mean, we went through some of the early adopters pain, right? So we tried it as soon as it was released. So, I mean, there definitely has been minor hiccups in here and there. But then what I found out was, you know, support team is very diligent about this service request. And I think Amazon Web Services fully on board with making sure that the cloud search product works. So we've had great support so far. But you know, I can tell you that just managing search myself, we had the worst problems. So it's nothing to compare. So I think so far it has been extremely smooth ride.
Yeah, we ran into similar kinds of things being early on. I think the biggest thing is we originally, I mentioned we have two search domains, one for recipe boxes and one for global recipes. We originally had those combined. And the way we did it is we basically put sort of the users in with the cloud search records. So in some cases, you'll have a food publisher, a blogger, who will promote a recipe on their front page. And everyone who goes there says, oh, that's a great recipe, and they add it to their recipe box. So you have this really unbalanced distribution of recipes in recipe boxes. Out of that 24 million recipes, I would say the vast majority of those are probably a very small percentage of our overall global recipes. And so what that meant is we had these really unbalanced records in cloud search. And that caused some real indexing pains for us. And that was, I think, our biggest challenge. We eventually solved that just by splitting our index in two, and it's been great since then. But.
Great. Yeah, I mean, I would come back to the experience that as a AWS service and as AWS, we're constantly innovating ourselves in cloud search and, to Pat's point, listening to feedback and trying to build a better search product and bring the features that are important. And we hear all of the pain, but nice to hear that overall positive experience. So last question. In what ways do you feel that search differentiates you or makes your offering better or stand out in the space that you're in?
One of my observations and one of the reasons we implemented search in our apps, we build a lot of news and sports-oriented apps, is you don't see search in a lot of apps. And so we really feel like, I'm proud of the fact that app and a lot of our other apps will have search. If you go to the CNN app right now, for instance, not to pick on them, hopefully no one from CNN is here, but you won't find search in a lot of apps. And so we feel like we won. We got there first, and it took us a couple of days. So we feel good about that.
Great.
I mean, in our case, there are a lot of mobile social video competitors out there, and then, I think with 2.0, which had a big emphasis on discoverability and explorability, and then geolocation search, hashtag search that really works, and media search that really works, and user search that really works, and then we're seeing, we definitely differentiated ourselves by having more focus on search and discoverability, and we're seeing pattern of other similar apps out there doing like similar hashtag search, and so they're like catching up. So, but we're glad that they were out there first.
Yeah, I probably don't have to say really much about this. Users, if you've got 1.6 million recipes, and that's growing every day, there's no way that you can sort of browse through those. So search is a requirement for users. When someone wants a chicken recipe or a broccoli recipe, that's what they expect. They expect to be able to type in chicken and get recipes that are very relevant for chicken, or broccoli and get relevant recipes. So that's sort of an imperative for the recipe box side of what we do, and that recipe organization and management. That's just is a crucial piece to that.
Great. Well, thank you so much, everybody, for coming out and hearing about search. Thanks to our guests, Pat Binkley, Ken Chung, Tim Ramsay.
Thank you.
And enjoy.